Good morning students. Today we are going to discuss about glycolysis. Already we discussed about which one aerobic and anaerobic respiration differences. This glycolysis is common pathway in both which one aerobic and anaerobic respiration. This glycolysis first discovered by three German scientists. Their names are Emden, Meyerhoff and Parnas. Emden, Meyerhoff, Parnas. These three scientists together they discovered glycolysis process in a cytoplasm of the cell. Cytoplasm of the cell. So we know that this glycolysis takes place in a cytoplasm of the cell. To the honor of these scientists, here we call it as a EMP pathway. EMP pathway. EMP pathway means Emden, Meyerhoff, Parnas pathway. It takes place in a cytoplasm of the cell. It is a initial step in which one aerobic respiration as well as anaerobic respiration. What is the substrate? Means here glucose is a substrate for respiration. Glycolysis is a first step in respiration. In that respiratory substrate is which one? Glucose. But generally in plants we can observe a presence of sucrose. Sucrose is a disaccharide. Initially it breaks down into which one? Fructose as well as glucose. These two molecules may enter into which one means glycolysis. Here glyco means sugar. Glyco means what? Sugar. Sugar means here which one? Glucose. Lysis means breakdown. What is that? Lysis means breakdown. Glyco means glucose. Now this glucose involves in a breakdown process. First glucose. This glucose is a 6-carbon compound. It involves in a glycolysis and produces which one means glucose 6-phosphate. Glucose 6-phosphate. Glucose 6-phosphate also 6-carbon compound, but here we can expect involvement of 1 ATP. Means 1 ATP is consumed and we can expect a releasing of 1 ATP in the presence of Mg+2 ion. So here the enzyme which one plays major role means hexokinase. Hexokinase enzyme plays major role. Is the first reaction. After this reaction we can expect a conversion of glucose 6-phosphate to fructose 6-phosphate. Fructose 6-phosphate. It is also 6-carbon compound, but we can expect a chemical change. So here the enzyme which involves means isomerase. In the presence of isomerase enzyme, we can expect conversion of glucose 6-phosphate to fructose 6-phosphate. Now this fructose 6-phosphate turns into fructose 1,6 bisphosphate. Fructose 1,6 bisphosphate. Here which enzyme involves means here we can expect involvement of kinase enzyme as well as here one ATP is utilized and we can expect formation of ADP. Adenosine triphosphate is utilized and produced adenosine diphosphate. Means one phosphate is incorporated in this fructose at the first carbon place. That's why it turns into fructose 1,6 bisphosphate. Now this fructose 1,6 bisphosphate involves in a cleavage reaction. Up to here whatever we discussed in these reactions we can expect a consumption of energy. Here we can expect which one? Consumption of energy. Consumption of energy takes place in these reactions. Now from here to reactions which all takes place in that releasing of energy takes place. So you understand here fructose 1,6 bisphosphate in the presence of enzyme aldolase. It turns into DHAP and glyceraldehyde 3-phosphate. DHAP means dihydroxyacetone phosphate. Here glyceraldehyde 3-phosphate. These two are which one means 3 carbon compounds. These two are which one? 3 carbon compounds. Now these substances may interconvertible in the presence of enzyme which one means triose phosphate isomerase. Triose phosphate isomerase, because these two compounds are which one? Trioses. Trioses means they possess 3 carbons. That's why we call them as a triose phosphates. Now this glyceraldehyde 3-phosphate involves in which one means a dehydrogenation process as well as a phosphorylation process. Here we can expect addition of one H3PO4 as well as involvement of which one means NAD. NAD turns into here which one? NAD H plus H plus. So this process is called a dehydrogenation process. Here which one? Phosphorylation. Here isomerization. Here phosphorylation. Again here cleavage. Now here we are expecting which one? Dehydrogenation process. In this dehydrogenation process, here we can expect formation of which one means 1,3 bis-phosphoglyceric acid. 1,3 bis-phosphoglyceric acid. This also possesses how many carbons? 3 carbons. So now this bis-phosphoglyceric acid turns into 3-phosphoglyceric acid. 3-phosphoglyceric acid. Now this 3-phosphoglyceric acid means here 1,3 bis-phosphoglyceric acid turned into which one? 3-phosphoglyceric acid. Means here we can expect a releasing of 1 ATP. Means ADP turns into ATP. Here the enzyme which one? Glyceraldehyde 3-phosphate dehydrogenase. Here the enzyme is which one? Glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase. In the presence of this enzyme, we can expect conversion of glyceraldehyde 3-phosphate to 1,3 bis-phosphoglyceric acid. Now we are expecting which one? Conversion of 1,3 bis-phosphoglyceric acid to 3-phosphoglyceric acid. Now this 3-phosphoglyceric acid means here one phosphate is eliminated in the form of which one means a substrate level phosphorylation takes place. This substrate will give which one? Phosphate to ATP and it turns into ATP. Same here we can expect involvement of which one? Mg plus 2, and here enzyme is which one means a kinase. Wherever the ATP involves in that reaction we can expect involvement of a kinase enzyme. Now this 3-phosphoglyceric acid turns into 2-phosphoglyceric acid. Means only we can expect a change in the position of which one? Phosphate. Remaining chemical structure is similar. Here the enzyme which involves means mutase. In the presence of mutase enzyme we can expect conversion of 3-phosphoglyceric acid to 2-phosphoglyceric acid. Now this 2-phosphoglyceric acid. Now this 2-phosphoglyceric acid turns into phosphoenol pyruvic acid. 2-phosphoglyceric acid turns into phosphoenol pyruvic acid. Here we can expect a loss of one water molecule. What we can expect? Loss of one water molecule. This phenomenon is called here dehydration. What we say? Dehydration. Up to here we observed energy consumption process. Now here we are observing which one? Energy releasing process now. In that first we expected releasing of one ATP when it is converted to 1,3 bis-phosphoglyceric acid to 3-phosphoglyceric acid. Now this phosphoenol pyruvic acid turns into pyruvic acid. In this situation also we can expect releasing of one more ATP. Means here we can expect involvement of which one? ADP and produces ATP. Here also enzyme which one? Pyruvate kinase. Pyruvate kinase. Here the enzyme which one? Dehydrogenase. Sorry. Here we can expect involvement of enzyme that is enolase. Which enzyme involves? Enolase. In the presence of enolase enzyme, 2-phosphoglyceric acid turns into phosphoenol pyruvic acid. This phosphoenol pyruvic acid turns into now pyruvic acid in the presence of kinase enzyme. Here we can expect a releasing of 2 ATPs. Means whatever the reactions we discussed from here to here, means from glyceraldehyde 3-phosphate to pyruvic acid, these all reactions are which one? Energy releasing reactions. Energy releasing reactions. So like this we are expecting 2 steps. One is energy consuming and another one energy releasing reaction. This is the end product of glycolysis. Which one? Pyruvic acid. How many pyruvic acid molecules are produced here? 2 pyruvic acid molecules are produced. Actually, we observe here only involvement of one, but DHA also it converts into glyceraldehyde 3-phosphate and it involves in this reaction. So finally, we will get which one? 2 pyruvic acid molecules. What does it mean? To get 2 pyruvic acid molecules, we can expect production of how many ATP molecules? Here 1 and here 1. Means total 2. 2 means this total reactions takes place 2 times, means 2 into 2, 4 ATP molecules are produced. 2 plus 2, total 4 ATP molecules are produced. During which one? Energy releasing process. As well as we are expecting here production of 2 NADH2 molecules. NADH2 molecules. From these NADH2 molecules, when these NADH2 molecules involve in oxidative phosphorylation, it produces, each one produces 2 ATPs. So 2 into 2 equal to 4 ATPs. Substrate level phosphorylation can produce how many ATPs? 4 ATPs. And oxidative phosphorylation produces how many ATPs? 4 ATPs. Means at substrate level phosphorylation, by oxidation of single glucose molecule we will get 4 ATP molecules. By oxidative phosphorylation we will get 4 ATP molecules. Total how many ATP molecules we will get from oxidation of a single glucose molecule? Totally means we will get 8 ATP molecules. But here energy consuming region we observed consumption of 2 ATPs. So here we can expect minus 2 ATPs gives rise to how many ATPs? Total 6 ATPs are net gain. So this is about pyruvic acid. Remaining class we will discuss later. Thank you.